this video, we'll understand the data visualization library called Matplotlib. So understanding the concepts of Matplotlib is very crucial for data analysis projects because it helps us understand the relations between different variables in a data set. For example, I have a data set of marks prediction of students. So I can find how many hours of study is properly related, how the hours of study is properly related to the result, or how the playing hours is properly related to the result. So I can visualize these things using data visualization libraries like Matplotlib. So we'll be going through two data visualization libraries, which is Matplotlib and Seaborn. And in this video, we'll be studying about Matplotlib. So let's go ahead and get started. Okay, Matplotlib is a comprehensive library for creating static, animated, and interactive visualizations in Python. Matplotlib is a plotting library for Python programming language and its numerical mathematics extensions NumPy. So as I had already mentioned you guys in the first video itself, in the previous video itself, that NumPy is the most important package that we'll be studying because each and every package apart from that requires NumPy for the mathematical calculations behind it. And as we'll be plotting data here, we'll be requiring NumPy to gather the data, and data manipulation will be requiring NumPy. Alright. And Matplotlib also provides an object-oriented API for embedding plots into applications using general-purpose GUI toolkits like WXPython, Qt, GTK+, etc. So what you can do is Matplotlib also contains an API for embedding your plots directly into this GUI based applications. We won't be doing this. We'll just be using Matplotlib to see how our data is properly related to each other. Okay, so let's go ahead and get started. I'll be sharing this link in the live chat. Right. So after you click on this link, you'll be redirected to this page. And as you can see, there are all the notebooks here. Over this course, I'll be updating more notebooks here. And you guys want to go ahead and click on the Matplotlib notebook that I have made. Just go ahead, click it, and open with Google Collaboratory. You can download this and use it in Jupyter Notebook also, as you guys want. So okay, I have already given you the definition of Matplotlib, and now we'll look at some pros of Matplotlib. Why Matplotlib came out to be one of the most used data visualization libraries, or why is it so helpful to us. So Matplotlib is a general purpose data visualization library, and it's very easy to get started on because it has simpler plots. For example, Matplotlib contains plots like line graphs or line plots. It consists of bar charts, it consists of pie charts, it consists of histograms, it consists of scatterplots, and it consists of 3D graphs and many more. So for any beginner to visualize data very, in a very broad aspect, or in a very, basic way, Matplotlib comes out to be one of the most important data visualization library. We'll also be using Seaborn, but Seaborn consists of more complex plots like joint plots, disk plots, and confusion matrix, and stuff like that. So heat maps. But what we'll be doing is we'll be taking Matplotlib now and understanding the relations behind different data points. Alright. So support for custom label and text. Matplotlib is this is another advantage of Matplotlib, is that we can customize all the labels and text in our plot, and it has a great control of every element in the figure. So each and every element that you can see in the figure can be customized here. Alright, and we can control each and every element and change it according to our needs. High quality output and mini formats. So Matplotlib generally gives a high quality output format only, and it's very customizable as I told you. So these are the pros why Matplotlib is considered to be a better selection over any other data visualization library to get started on. Okay, the first thing we'll do is we'll be importing our Matplotlib library. So what we'll do is we'll use this command called import matplotlib.pyplot as plt. This pyplot, what it does is basically it's a collection of command style functions that make Matplotlib work like MATLAB. So MATLAB is another software. I'll just show you guys. So MATLAB is a multipurpose numerical computing environment and proprietary programming language developed by MathWorks. So MATLAB is a multi-paradigm numerical computing environment. So all numerical based computations and all, Matplotlib is a go-to tool. All right, and so what pyplot does is that it's a collection of command style functions that make Matplotlib work like MATLAB. So for each pyplot function makes some change to a figure. Alright, so creates a figure, creates a plotting area in the figure, etc. Right. So, and this PLT is the alias that we'll give to Matplotlib because we'll be referencing it again and again, and instead of calling it matplotlib.pyplot, each time we'll use this alias. This is a alias that is used generally by each and every programmer or each and every data scientist. So what you can do is you can choose any name that you want, but let's go with PLT because this is a general way of referencing our Matplotlib library. So after importing this, we'll also be requiring NumPy for the basic numerical computations. So we'll also be importing NumPy. Alright, let these get run. So now what we'll do is we'll take some points to plot. So I'll create a variable called x and I'll store an array in it which consists of 0 to 10 and y consists of 10 to 20. And I'll also create two more variables, two more data points here, and a and b, naming a and b, and which will a will have the values of 2, 4, 8, and 12, and b will also have the values of 4, 8, 16, and 24. So as you can see, b has the relation of 2a, b equals to 2a. These two have the relation of b equals to 2a. And when we'll go ahead and plot the graphs, you will see that they give a straight line saying y equals to 2x. Alright, and let's just go ahead and print the shape once. Let's check the shape. What do you guys think the shape would be? When I do b dot shape, okay, so b is an array which consists of 4 elements. That's why this is the shape of the b array. Okay, now line plots. It is basically line plot is basically connecting data points with a straight line. It is useful in understanding the trend over time. So any data set that I have, say we have to predict, let's say we have to predict the prices of a price of a commodity, changing over time. Or let's say I have to a very basic example, a very common example would be your house price prediction. There's a huge data set called California housing data set, so we'll be doing EDA on that. So what we'll do is, we have to predict how the changes of the California housing data set over time. So if anything over time comes into play, then we'll always be using line plots, to check the trend over time. So it can explain the correlation between points by the trend. An upward trend means positive correlation, and a downward trend means a negative correlation. It is mostly used in forecasting and monitoring models. Okay, when to use? You need to keep this in mind. It's a very important point that line plots should be used when single or multiple variables are to be plotted over time, as I already mentioned it to you guys. So example would be, stock market analysis would be another example, and weather forecasting can be another example. So I have these points here that I created X and Y, and I'll just go ahead and plot this point now. So we'll be referencing our PLT alias here for the Matplotlib library, and then we'll be passing this method called PLOT. So the PLOT method helps us create a line plot. So plot is therefore line plot, and we'll be passing our data points here. As you can see, I have passed x and y, and I'll create a label for the x-axis called x-axis, and I'll name it x-axis, and also for the y-axis I'll create a label and I'll name it y-axis. And let's comment out this thing. I'll tell you what this thing is. Let's go ahead and print this one. So as you can see, I've created this line plot over here, and the x label is shown here saying x-axis, and this is the y label called y-axis, and this is the plot over time, or let's say this is the plot of this graph. And as you can see, this is the extra information that is provided to us here, and if we don't want to see that, we can use the plt.show method here, and then when I run it again, this thing, the extra information will get hidden. Alright, so let's say I don't want this so the default color of any line plot in your any Python notebook would be blue, and if I want to change that, I can do that. So what I'll do is, let's say I'll make pass this function again, and now what I'll do is, let's say I don't want this to be a straight line, I want this to be a dashed line. So I'll pass the dash parameter here, in single quotations or double quotations, doesn't really matter. And I'll also pass a parameter of color. Alright, also pass a color parameter and name it R. So R stands for red. You can type red, or you can also type the first letter, doesn't really make a difference. And I'll just go ahead and print it again. So as you can see, this line plots gets printed with a dashed line and a red and red color. So now let's say I want to create subplots of each and every of the line plots. Let's say I want to create 3 line plots. So what do? I use the subplot method here. So now the subplot, what it does is basically it takes these call signatures, n rows, n columns, index. So what I'll do is, this is 231 is nothing but 2 rows, 3 columns, and this is the first subplot that I'll be creating. This is the first subplot that I'll be creating, and this is the second subplot that I'll be creating. Alright. So I'll be referencing this thing again, this method again, to create the line plot. And the first plot will be in a dashed line, and the second plot will be a normal line, but it will have a green color. So let's go ahead and print it. As you can see, now let's say I don't want this to be a straight line, but I want this to be having a circular marker. So what I can do is I can just pass this thing with the color itself, and when I go ahead and print it, so as you can see, it comes to be a circular marker. Now scatterplots. So scatterplots helps in visualizing two numeric variables. It helps us identifying the relationship of the data with each variable, that is correlation or trend of patterns. It also helps in detecting outliers in the plot. So when to use? It is used in machine learning concepts like regressions, where x and y are continuous variables. It is also used in clustering and clustering or outlier detection. Just one second. Okay. Okay, this is not an example of scatterplot. Okay, this is an example of line plot itself. Scatterplots, I haven't made anything of scatterplots. I'll just go ahead and make it. It's no problem. Let's see this first. So let's say I want to plot a cosine curve. What I can do is I'll pass the x variable here, of ranging from values 0 to 4 pi. np.py is nothing but the value of pi, as you can see. So to show you. P dot pi is nothing but 3.14, the value of pi. So this x goes from 0 to 4 pi and with a step of 0.1, and y is nothing but the cos x function. I'll just go ahead and print this graph again, naming the title to be a cosine curve. We can name our graph, give the title to our graph by using the title method, and we'll just go ahead and plot the graph now. The cosine curves gets printed here. As you can see, the title is mentioned over here. Similarly, I'll go ahead and print the sine curve. Let's say I want to change my sine curve and again make it to be a circular marker and a red line one. Okay, so as you can see, this is also true. Now let's go ahead and head over to bar graphs. So bar plot shows the distribution of data over several groups. It is commonly confused with histograms, which only takes numerical data for plotting. It helps in comparing numerical values. So this is very important because bar charts and bar graphs is basically used to compare numerical values. When to use, it is used to compare between several groups. As you can see, let's take this example. Let's say student marks an exam. For example, take the situation that I have two classes, and then I'll plot the marks of the different class in in different subjects. So let's say class A in subject A has got this much marks, and class BE in the same subject A has got this many marks. So as you can see, bar charts are always used to compare between the two groups. I'll go ahead and create these arrays, data points again, where x will be nothing but a data set, an array ranging from 0 to 4, and y will be a random array consisting of values from minus 1 from minus 1 to 1. Sorry, any random values. And let's go ahead and print this vertical bar graph. So for bar graph, we use the BarH method here and pass our values here, pass our parameters here. So I'll use the x and y here, and then go ahead and print this graph. So as you can see, the first y value was minus 1.3, which is a very big negative value. So therefore this thing is coming out to be in a negative scale. And let's say student marks cannot be. Let's go ahead and just print the student marks. Let's go ahead and print the student marks and see. Okay. Now y will be a value from 5 to 9, and this thing should all be positive. So as you can see, let's say I have this class, this class, this class, and each and every class in the same subject has got this much of marks in the y-axis. So as you can see, this thing in the fifth group has got the most marks. So bar graphs are generally used to compare values or compare between different groups. Now let's say I want to compare these datas. Okay, so I'll create these two arrays, and similarly I'll create these two arrays also. And then what I'll do is I'll go ahead and plot that I am plotting these all four data points in the same bar graph. So what I'll do is I'll plot this thing here uh, by using the BarH method, and similarly these two data points here by using the BarH method again. But let's say I'll change the color for better understanding. So I'll change the color to be pink, and I'll use the title as bar graph and the successive labels also. So as you can see, it gives us a very good picture of how different groups are, correlated to each other, or rather how different groups are, related to each other, as in which is greater, or for a very better comparison of these groups, bar graphs are used. Okay, horizontal bar graphs. So for horizontal bar graphs, what we do is we use the BarH method. So by using the BarH method, what we do is this H stands for the horizontal thing. And let's say I want to plot these points here again, these points here, and let's change the color to be cyan. And let's go ahead and put it. So as you can see, now I transform my vertical bar graph to a horizontal bar graph. Okay, this is the way to create subplots within your Matplotlib. Okay, just go ahead and read this once. So this is nothing but we'll use the axis dot zero bar here. This is the first method. Sorry, the first element in our axis array, and then this is the second one, which will be a horizontal bar graph. And let's go ahead and print it once again. So these two are the subplots where the first bar graph is a horizontal bar graph, as you can a vertical bar graph, as you can see, and the second one is a horizontal bar graph. I can change the color to be anything that I want. Let's say pink, for example. Okay, as you can see, this helps in a better understanding of the two graphs. Now pie charts. It is a circular plot which is divided into slices to illustrate numerical population. The slice of a pie chart is to show the proportion of parts out of a whole. When to use? Pie chart should be used very rarely, okay, as it is difficult to compare sections of a pie chart. Bar plot is used instead of comparing section. Bar plot is used instead of comparing sections is easy. Okay, bar plot is used instead as comparing sections are easier in bar plots. And we will generally not be using it a lot. Pie charts won't be used a lot, but let's say I want to use it, I'll just show you how to go ahead and use it. We'll be using this generally in these kind of examples. Bar pie charts should be used, market shares, or where each and every share should be shown or can be shown visually. We'll use pie charts. So let's say I want to plot this data where I'll have these labels in I'll create these labels, okay, and then I'll create each and every size here. And what I'll do is I'll explode first. I'll reference this thing. Now what this does is we use the pi method here. And now what we do is first parameter to be passed is are the sizes of the bar chart, sections. Then we pass the explode parameter. Next, what we do is we use the labels, and these labels should always match the sizes. Alright, and the auto PCT method we use, where this will be how we want to show the percentages in our graphs. Okay, okay, as you can see. So what this explode method does is it takes this thing out of the graph. So this part is getting exploded from the pie chart, and I exploded my first slice here. So that's why the first slice is getting exploded from the pie chart. And the auto PCT method here shows that I'll plot my let's say I'll plot my or the percentages in this format. Now let's head over to histograms. So histogram takes place in a series of data and divides the data into a number of bins. It then plots the frequency data points in each bin. It is useful in understanding the count of data ranges. When to use? When should we use histograms? Histograms should be used when we need the count of a variable in a plot. Alright. The number of particular games sold in a store. let's say this is the example of this. I want to plot the, let's say I have a game store and I have sold many different games. Now I want to plot the, plot the how many games, plot each and every frequency of the games that I have sold. So in that problem, we'll use histograms. So this is the data array that I have provided, ranging from 21 to 100 in a random order. And let's say I want 5 bins. So we'll use the hist method here for histograms. I'll pass the data, which is the array here. I'll use the color pink. I'll use the edge color to be black. And bins should be equal to num bins. So I'll have 5 bins. So let's go ahead and print this. So as you can see, I created 5 bins, and color of uh, bin should be pink, and the edge color of each and every bin should be black. So this is a very good visualization for data points where we need a count of a variable in a plot. Let's say I want how much, or let's say the quantity of each and every data points. We want to get that. So histograms is the best example to do that. This is a cumulative histogram. Say I want to print this data in a cumulative format. So what I do is I pass the method called cumulative, and I give it to be true. Say I want to change the color, I can do that anywhere. Color request. I just have to mention the color parameter here, and let's say I want to do this pink again, and the edge color to be black. So this is a cumulative graph. Alright, okay. Now let's go ahead and give you guys an example of scatterplots. It is quite useful. Let's take the example from net. Okay, so this thing that I showed you is also a scatter plot. Okay, I was wrong. This is also a scatter plot. My mistake. I'm so sorry. And we can also create scatter plots by using the scatter method here. And let's say I want to create this thing. So x and y are now the points, these points. So that's what this is getting printed. Let's go ahead and print this. Let's just go ahead and print this first. And now let's print this thing. So as you can see, scatter plot is basically, uh, we use this very extensively in concepts of regressions where x and y are continuous variables. So x and y, as you can see, these are in fact continuous variables here. And what we do is for clustering scatters, we use this. It's also used in clustering scatters or outlier detection. Scatter plots are very important which helps us visualize, two numerical variables. All right, so these were the basics of your Matplotlib visualization library, data visualization library. So after understanding these concepts, you can go ahead, take this notebook, or you can start doing some EDA on your notebooks from Kaggle or any other data set that you like. Go ahead, download it, do some data visualization, data analysis on those projects, and see how each and every variable is related to each other. Because I have already taught you NumPy, I have taught you Pandas, I have taught you Matplotlib. So these are the basic libraries that are required for to get started with any data science project. What you can do is go to this link, and I'll be sharing it with you guys. So go to this link, and in datasets, you can go ahead and download the student score.csv dataset. Okay, and just check. Just load this dataset first and just check, how hours of study is related to the passing parameters, or how scores is related to the passing parameters here. All right, just go ahead and do that. All right, with this, you understand the basic concepts of Matplotlib, and thank you guys for watching, and please catch me in the next video.